Welcome to this video on the topic of exponentials. In this video, we're going to have a look at how we can solve for the unknown within an equation where the unknown is held within an exponent. Now this can be done in simple equations using a method called inspection. This is achieved by matching the non-exponential parts of an equation and then equating the exponents. So this only really works if the equation's a nice simple one. Now looking at examples of how to do this, in a over here we have 2 to the power of x plus 1 equals 1 over 8. What we're going to do is, as this says here, we're going to try and match both sides of the equation and then we're going to equate the exponent parts. Now as you can see on the left here, we've got 2 to the power of x plus 1. We can't really do anything with this over here, so where we turn our attention to is the right hand side where we've got 1 over 8. So what we're going to try and do is we're going to try and make this right hand side here look as similar as possible to this left hand side here. Now to do this, the first thing we're going to notice is that on the right hand side we're dealing with fractions. What we want to do is we want to get rid of this fraction because there's no fraction over here. So to do this, I see that there is a 1 over 8. I can remove the fraction part by simply grabbing the 8 and raising it to the power of -1. And it's still 2 to the power of x plus 1. Now next step is I'm going to have a look at the 8. And I'm going to say I've got 8 over here. Let's try and factorize this. We've got 8, we can divide it by 2. Which gives us 4, and we can divide 4 by 2 as well, which gives us 2. So we've got factors on the left hand side of our factor tree here, and therefore what we can see is that on the right hand side we're going to get raised to the power of -1. We're going to have 2 to the power of 1, 2, 3. And then on the left hand side we've got 2 to the power of x plus 1. Working our way down, we bring the 3 and the -1 over here together. So we're going to get 2 to the power of -3. And then we still have 2 to the power of x plus 1. Now what we can see is that everything looks similar outside of the exponents. So our next step is we can get both exponents, so x plus 1, and then equate them such that x plus 1 is now equal to 3. Solving for the unknown, we have a constant on the right, we don't want it there, so we take 1 from both sides, and what that results in is a result of x is equal to -4. Verifying that this is the correct solution, we can use our technology. So I'm going to say up we come to the calculator, and what I'm going to do is I'm going to use the equation solver function in this calculator. To do this, I'm going to go into option, F4 for calc, solve, and then I'm going to key in the equation. It's 2 to the power of x plus 1, shift equals, and it's equal to 1 over 8, comma, then I'm going to put solve for x. Closing it off, I execute. Lo and behold, the calculator agrees that the value for x is -4. So we can also use our calculators to verify these solutions here. We still have to know how to do this, but this is just a nice tool for verifying. Alright, started off simple. Let's go 1 degree of difficulty harder. Let's work with some radicals. On the left hand side we have 49 to the power of x, and it is equal to the 6th root of 343. What we want to do is solve for x as shown over here. Now to do this, it's a little bit more complicated in that with the first one here we only manipulated the right hand side. For this one we're going to manipulate both the left and the right hand side. Starting off, I'm going to try and factorize the large numbers that I have here to see if there's some form of pattern that I can do to match these up. Now looking at that, I've got 49 and I'm going to do a factor tree. The factors of 49 are 7 and 7. So that's a nice simple one. For 343, the factors for this are, well, I'm not quite sure, so I'll bring up my calculator and I'll use that as a tool. I'll go 343. I know it's odd, so I'm not going to try and divide it by 2. So I might go for 3. That doesn't work. We'll go to, I know 4's not going to work because again it's odd. Let's go for, well, 5's not going to work because it ends in a 3. Possibly 6. No. Let's keep going up. 7. And I've got a whole number. So I know one of the factors is 7. The other remaining one is 49. And of course, because I know my 7 times tables, I know that the factors of 49 are 7 and 7, as shown on the left over here. So here are my factors. Putting this together to simplify my equation, I'm going to have 7 to the power of 2, x, and then I'm going to have the 6th root of 7 to the power of 3. Alright, next step is I want to turn my attention to, well actually I'll simplify the left hand side out a little bit more and I'll bring the exponents together. So it's going to be 7 to the power of 2x. So the exponents multiply because the bracket's been raised. And then on the right hand side I'm dealing with a radical, so I've got 7 to the power of 3, and removing this radical symbol I can do it by grabbing this 6 over here and raising it to 1/6. Bringing the two exponents together, they're going to multiply, so it's going to be 7 to the power of 3 over 6, and I know that 3 over 6 is exactly the same as saying a half, so it's 7 to the power of a half. And on the left hand side it's 7 to the power of 2x. So what we've done is we've matched the bases over here. So the next step is we're going to equate the exponents. Doing that, I'm going to get 2 to the power of, I'm going to get 2x is equal to a half. Now I don't care about what 2x is, rather I care about what x is, so I'm going to divide both sides by the coefficient of x, which is going to leave me with x is equal to a half divided by 2, and using my fractional division I can turn it into times and a half, which in turn reveals an answer of a quarter, or I can say it's 0.25, however you want to represent it. Verifying that this is indeed the correct solution, I'm going to grab my calculator once more and I'm going to use the solving function. So I go F1 for solve, I'm going to key in the original problem, and I'm solving for x. Hitting solve, lo and behold, I get a value of 0.25 or a quarter, however you want to represent it. Alright, we're now experts at dealing with radicals. Let's have a look at something 1 degree of difficulty higher. Over in C here we have 2 multiplied by 3 to the power of x plus 5 is equal to 18. What we want to do is once again solve for x. Now on the left here, what you can see is that there isn't a whole lot we can do to try and represent this in a simpler form, but 18 over here, I reckon we can factorize this. So what we're going to do is we're going to get our 18 and we're going to draw one of our humble factor trees. Now looking at this, first question I ask is, can I divide 18 by 2? And in this case I can, and if I divide 18 by 2 I get 9. After that I ask, can I divide 9 by 2? I cannot. Can I divide 9 by 3? I sure can. I'm going to get 3. remainder 3. So therefore, what I can say is that the factors of 18 are 2, 3, and 3. Now, why this is useful is that when I rewrite this equation out, I can have 2 multiplied by 3 to the power of x plus 5, and then on the right hand side I can have 2 multiplied by 3 to the power of 2, because I've got a 2 here and it multiplies with 3 times 3, which is 3 squared. Now what we can see is that we're in a very similar form to what we want to, or we're in a very similar form such that if we wanted to, we could equate the two exponents. But we're going to go one more step further. We don't really need to do it, but we'll do it anyway to prove the point. We want to get rid of these 2's here. So let's say bye-bye by dividing both sides by 2. And that's going to give us 3 squared on the right and 3x plus 5 on the left. And therefore, we've got a case of matchy-matchy. So what we can do is we can grab the exponents and equate them. Equating these exponents, we get x plus 5 is equal to 2. Solving for x, we have a constant out of place. We want all constants on the right hand side, all variables on the left. So I'm going to subtract 5 from both sides. That is going to deliver me to the answer of x is equal to minus 3. Verifying that this is indeed the solution to the problem, I bring up my calculator. I'm going to use my solving skills again. Keying in the equation, I'm going to go to Option, Calc, Solve. Then I'm going to go 2 times 3 to the power of x plus 5, all equal to 18. And I want to solve for x. Hitting execute. Lo and behold, the value of x in this case is -3, and this is in agreement with the calculated value. Alright. Final and nastiest problem. We have 4 to the power of x plus 2 to the power of x minus 20 is equal to 0. Once again, we want to solve for x. Now this question here probably looks not too bad, but it's got a pretty tricky twist in it. Now solving this, what I'm going to do is I'm going to go everything is equal to 0. I'm not going to do anything about the 20 yet. I am not going to do anything about this 2x yet, but what I am going to work with is this 4x here. What I'm going to do is I'm going to factorize 4 into the form of 2 squared raised to the power of x. Then I'm going to get the minus 20 and keep it there. 2 to the x, and I'll leave it there. But I'm going to go on this leftmost term over here and swap the 2 and the x's around. So we'll have 2 to the x inside the parentheses and the squared outside. Now next step that's probably not so obvious is I'm going to struggle if I try and solve it in this form. So what I'm going to do is I'm going to change the form in such a way that I'm comfortable solving that sort of problem. So what I'm going to say is I'm going to say let y equal 2 to the power of x. Then it's going to reveal the question as being something a little bit outside of our topic. We get 0 on the right still, constant of minus 20. Then our middle term is going to turn into y, and then our leftmost term is going to turn into y squared. So what we find is that this initial problem up here is in fact a trinomial or a quadratic problem. Solving this, we're going to factorize the trinomial over here, and then we're going to solve for y using the null factor law. To do this, I turn my attention to the 20, ignoring the minus at the moment, and I ask myself, what are the factors of 20? Now the factors of 20, starting from 1, we have 1 times 20. 20 is even, so it can be 2 times 10. 3 is not a factor. However, 4 is indeed a factor, so it could be 4 times 5. And if we wanted to keep going, we can have 5 times 4, but we're not, because we've already got this factor over here, 4 times 5. Perfect. Alright, now, our attention now turns to the middle y here, or more importantly, the coefficient in front of y, which is an implied 1. So it's 1y. Now the question at hand is, what two factors here are going to add together to give 1? Keeping in mind that we're dealing with a negative 20. So one of these factors is going to be a negative. So if we go minus 1 plus 20, it's going to be 19. Or if we go 1 plus minus 20, it's negative 19. So this guy's not going to be one of them. Next we have 2 and 10. We can go minus 2 plus 10, that will give us 8. Or we can go 2 plus minus 10, which will give us negative 8, which is not a contender. But lucky last, we have 4 and 5. Minus 4 plus 5 is 1. So what we can see is that we're going to have a minus 4 here and a plus 5 here. So sorting this out, we have minus 20 and y squared staying the same. However, where we're changing it up is we're going to give it a 5y minus 4y. So we split this factor in here. Next step is we're going to factorize. So looking at this, set up my brackets. The common thing between 4y and 20 is going to be the minus 4. Left over is y plus 5. Then these two terms here, common factor is y. We're going to get y plus 5. Finishing this off, I have a common factor of y plus 5 and y plus 5. If I factorize for that, what I get left over is y take 4. And all of this is still equal to 0. Now because all of this is still equal to 0, what I'm doing is I ask myself what values of y will force the left hand side to equal 0. Well, it's going to be y is equal to the opposite of minus 4, which is positive 4, or the opposite of plus 5, which is minus 5. So our values of y are 4 and minus 5. Now to this point, we probably got so wound up in solving this wonderful quadratic over here, we forgot the initial problem was solving for x. So what we do is we remind ourselves that we are solving for x, so x being y equals 2 to the power of x. So let's say y equals 2 to the power of x, and we're done with y, so we're going to say but y is equal to 4 or minus 5. Now it's at this point we have to look. We think to ourselves, is it possible to get a negative from 2 to the power of x? And in this instance it's no. So what we find is that y has to be a positive real number. And what that means is that we can scrap this positive, or this guy over here. So therefore y is going to become 4, and 4 is equal to 2 to the power of x. Factorizing 4, it becomes 2 to the power of 2, 2 to the power of x. Equating the exponents, we find that x is equal to 2. So a bit of a tricky question, requiring a number of different mathematical tools from our mathematics toolbox. Checking, of course, that this is indeed the correct answer, I bring my calculator up, I go to Option, Calc, Solve, and I'm going to key in the initial problem here. 4 to the power of x plus 2 to the power of x minus 20 is all equal to 0, and we are solving for x. I click execute. It takes a little bit longer. it's a tricky problem, but it indeed tells me that I've got x equals 2, so we're in agreement. So in summary, what we had a look at in this lesson was how we can solve for unknowns in exponential equations where the unknowns in the exponent. First example we looked at is where we don't have to modify the left and we just match the right to the left. Second example involved matching both the left and the right hand side, and also more importantly dealing with this radical symbol here. Third example we looked at when we've got a coefficient in front of this base here, so 1 degree of difficulty higher. It's a little bit tricky. And then finally in D, we're solving when we have to deal with like a quadratic situation here, so probably the trickiest of them all.